Hello student, you are welcome to GChem FreeChem. This channel is specially for the student who don't need to go for the coaching, otherwise we do not afford coaching fees. We have specially prepared this channel for those students who want to study, who want to do self-study at home, and it proved very useful to them. In today's lecture, we will see what is the Lewis dot diagram and we will study various Lewis dot structure. The topic that we will discuss in our today's lecture, that is how to calculate valence electron in various element. Then how to know the maximum valency, because whenever you are going to draw a Lewis diagram of polyatomic molecule, on that time this concept is very essential. You must know this concept, then and then you are able to draw the Lewis dot diagram of polyatomic molecule. Then how to calculate the formal charge. This is also one of the most important calculation that we need for drawing the Lewis dot diagram. Then we will go through some rules that we must know for drawing the correct Lewis dot diagram. And during lecture we take 10 example, some crucial and complicated example of polyatomic molecule for drawing the Lewis dot diagram. So first, how to calculate the valence electron of various elements. Friends, valence electron can be calculated based on two methods. One that is called group method, and second that is called electronic configuration method. In a group method, if we are knowing the group number of element, we can say very easily how many electrons are there in that element. For example, if your element belongs to group number 1, then its valence electron is 1. Similarly, if your element belongs to group number 2, then number of valence electron in that element is always 2. This is about S block, because in S block only 2 groups are there. If we talk about the P block element, then group number 13 to 18 are there in P block. So if your element belongs to group number 13, then number of valence electron are 3. To remember this, we are using the trick that in a P block, skip the first digit of group number and second digit is the valence electron. In a 1, 3, 13, 1 is the first digit that we have to skip, and second digit, that is 3, and 3 is the valence electron. If your element belongs to group number 14, then skip the first digit, that is 1, and second digit, that is 4, is your valence electron. Similarly, if it belongs to group number 15, then valence electron are 5. If group number 16, valence electron are 6. If group number 17, then valence electron are 7. If group number 18, valence electron are 8. Right? So just by knowing the group of that element, we can easily say how many valence electrons are there in that group. So this was all about group method. Now second is electronic configuration method. In an electronic configuration method, we must know the electronic configuration. That's the electronic configuration we are drawing based on energy level. There are two types of electronic configuration. One is called the detailed electronic configuration, that is based on suborbital, and other one that is based on energy level. For example, if your atomic number belongs to say 0 to 20, so you can say up to 20, then the electronic configuration that you have to follow is, I'm writing here, electronic configuration. Then you have to follow the electronic configuration that is 2882. If your atomic number is from 21 to 38, then you have to follow the electronic configuration that is 28182. The difference between these two rows is that in the first row there was no 18, but in second row we have put 18 between these two 8. So in between initial and final two digit 28, we have placed 18 here. Similarly, here we have added 18 to 20. So 20 plus 18, that is 30. We have added 18 here. That's why we have placed the 18 here. This is the short trick of remembering corresponding electronic configuration. If your element having atomic number is from 39 to 56, if it is a 39 to 56, then you have to follow the electronic configuration that is 28 18 18 8 2. Again, the difference between these two rows is that in this row only 1 times 18 was placed in between all these digits, while here we have put 2 times 18 in between this row. So again, if you add 18 to 38, it becomes 56. So 38 plus 18, the 56. That's why we have placed one more time 18 here in between this row, in a center of this row. Similarly, every time just add 18 here, put 18 here in the center, and every time you will get respective electronic configuration. Now let us see how to use this electronic configuration to calculate the valence electron of various element. Suppose we are having a phosphorus. Then in phosphorus, atomic number is 15. And phosphorus having atomic number 15 means it will fall in this first row. 15 is lying in between 0 to 20. So we will follow this electronic configuration, that is the 2882. Now 15 atomic number means phosphorus having a 15 proton, and we know, friends, number of proton and electron are always equal in an atom, any atom. So total 15 electrons are there in this electronic configuration. So we have to maintain 15 electron in this standard electronic configuration. So 2 plus 8, that's 10, plus 5, 15. So I will delete this 8 and put 5, and I don't need this 2, that's why I am deleting this 2 also. So total I am having a 15 electron, 2 plus 8, 10 and 5. So this 5 is nothing but valence electron of phosphorus. In this way you have to use this electronic configuration. Let's take one more example, that's the, say, calcium. So calcium having 20 atomic number. So electronic configuration again belongs to 20 is 2, 8, 8, 2. 2 plus 8, 10 plus 8, 18 plus 2, 20. So this standard electronic configuration is exactly complies with this atomic number. So I will say the last digit is my valence electron. So 20 is the valence electron. For example, if we take a selenium, then selenium having atomic number, that is the 34. So 34 is belongs to this second row. So I have to first write down the standard electronic configuration, that is 2, 8, 18, 8, 2. This is the standard electronic configuration. Now I have to maintain total 34 electron because 34 protons are there. Once 34 is the atomic number, means 34 protons are there. So in order to maintain the 34 electron in this standard electronic configuration, I have to calculate like 2 plus 8, 10, plus 10, 20, plus 8, 28, plus 6, 34. So instead of 8, I must have 6 here, and I don't need this 2. So new electronic configuration of selenium is 2, 8, 18 and 6. So definitely this last digit 6 is the valence electron of selenium. Likewise, you can draw electronic configuration and you can know the respective valence electron. Let us take one more example. Say tin, right? Tin is denoted by Sn. Atomic number of tin is the 50. So if atomic number is 15, then it's corresponding to this electronic configuration, because 5050 is falling in this range 39 to 56. So I have to follow electronic configuration, that is 2, 8, 18, 18, 8, 2. So very first I will write down 2, 8, 18, 18, 2. Now total 50 is the atomic number, so 50 electron I have to maintain here. So 2, 8, 10 plus 18, so 10 plus 18, that's the 28, again 10, 38, again 8, 46, right? So 2, 8, 18, 18, 46 is there. Now I have to put 4 here, 4 here. So my 2, 8, 18, 18, sorry, 8 is here and 2 is here. So instead of 8, I put here 4. Why? Because by adding the 4, I will get the 50 number of electron. So this 4 is nothing but valence electron of tin. In this way, we can calculate any valence electron of any element very easily by using these two methods. So we have solved this, how to calculate valence electron. Now let us see how to know the maximum valency. To know the maximum valency, again we will use our electronic configuration, because electronic configuration always help us to know the maximum number of bond that element can make. Maximum valency is nothing but maximum number of bond that my atom is making. So let us see, if your oxygen is there, say oxygen is there, then oxygen having maximum valency is equal to 2. What does it means? Means oxygen can form maximum 2 bond. Until unless oxygen is not forming 2 bond, it's not stable. So oxygen is they are in a center atom, it always trying to make a two bond. So whenever you are drawing the Lewis dot diagram, and if you are finding oxygen having only single bond, then always try to make a two bond, because its maximum valence is 2. Similarly, if you take the sulfur, then sulfur having maximum valency, that is the 6, maximum valency, that is the 6. If you go with the nitrogen, then nitrogen having maximum valency, that is 4. Similarly, if you go with the phosphorus having maximum valency, that is 5. If you go with the carbon, then having maximum valency, that is 4. If you go with the silicon, I'm taking the measure elements. I'm taking the example of elements. Those are widely used as a center atom in a Lewis dot diagram. So if you are able to remember only the valency of these 3 or 5 elements, it's very enough for you. And I will give you trick also how to calculate this valency. So silicon having maximum valency, that is equal to 4. Now let us see how we can know the maximum valency from electronic configuration. For knowing the maximum valency, we must have idea about the detailed electronic configuration. For example, oxygen's detailed electronic configuration. Very first, oxygen having a atomic number, that is the 8. So corresponding to 8 atomic number, electronic configuration is 1s2, 2s2 and 2p4. 2p4. Now in a 2p4, we know friends, p orbital having total 3 house. So 1, 2, 3 and 4. So only these 2 electrons are available for making the bond. That's why maximum valency of oxygen is 2. Similarly, sulfur having an atomic number is 16. If we draw the electronic configuration of sulfur, then that is the 1s2, 2s2, 2p6, 3s2 and 3p4. So number of valence electron 2 plus 2 4, 6 10, 12 and 16. Now valency is always depends on the valence orbital. Now here this is the first energy level, this is the second energy level, and this is the third energy level. So its outermost orbit, that is the third energy level. And how many electrons are there in a third? That is the total 6. Totals are 6. So we can say 2 plus 4, 6. That's why its maximum valence is 6. Similarly, if you talk about the nitrogen, then nitrogen having a 7 atomic number and electronic configuration corresponding to 7 atomic number, that is 2s2, 1s2, 2s2 and 2p3. So in its valence orbital, outermost orbital, there are 2 plus 3, 5 electron. But as you know student, one of them is the always used as a lone pair electron. That's why its valency is 4. Out of 5, 1 is the lone pair. That's why its valency is 4. Similarly, if we go with the phosphorus, then the atomic number of phosphorus is 15. So its electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p3. 2 plus 2 4, 6 10, 12 and 15. Again its outermost orbit, that is the third one. This is the first energy level, this is the second energy level, this is the third is the outermost energy level. So in outermost energy level, total 2 plus 3, 5 electrons are there. So its valency is 5. If you talk about the carbon, why carbon having the 4 valency? Atomic number of carbon is the 6 and its electronic configuration 1s2, 2s2, 2p2. Again valence orbit is the second energy level. Total electrons are 4, so its valence is 4. Similarly, if you go with the silicon, then its atomic number is 14 and electronic configuration with respect to 14 atomic number, that is the 1s2, 2s2, 2p6, 3s2, 3p2, 2, 4, 6, 10, 12, 14. Again, this is the first energy level, second energy level, the third energy level. Third energy level is the outermost orbit. Outermost orbit is identified as a valence orbit, and in a valence orbit total 4 electrons, that's why its valence is 4. In this way you can calculate valency of any element. Okay, if you are knowing the detailed electronic configuration. How to draw the detailed electronic configuration, we are having a special video for this in our channel. Now, how to calculate the formal charge? How to calculate the formal charge? Once we are aware with the formula of formal charge, we can calculate it very easily. Friends, the formula for calculating the formal charge, that is the formal charge is equal to V minus L minus B2. Mnemonics for this is V love B2. V love B2. B2 means B by 2. Right? This is the mnemonics by through which you can remember it by such small and short tricks. Now here V is nothing but it's a valence electron. V is the total valence electron. L is nothing but lone pair. Lone pair are the electron that not participating in the bonding. B is the number of bond. B is the number of bonding electron. Number of the bonding electron, and divided by 2. So here, if we want to calculate, let's take one example so we can easily understand what is the formal charge. Okay. For example, NO2, right? In NO2, what is the formal charge of this oxygen, this nitrogen, and this oxygen? So, if we want to calculate formal charge of this oxygen, so you can say that formal charge first, then very first you have to know the valence electron. Friends, we know oxygen belongs to group number 16, so total valence electron in oxygen is 6 minus lone pair electron. Here on oxygen total 4 lone pair electron. Why 4 electron? Because 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons are there around oxygen. Out of 8, 4 are in sharing with the nitrogen and 4 are as a lone pair. 4 electron that are in a sharing with nitrogen are called bonding electron because they are not free now. But these 4 are not used in a bonding, that's why we are calling it lone pair electron. So there are total 6 lone pair electron. Total how many electrons are there, friends? 4 lone pair electron, right? Minus how many bond pair electrons are there? So 1, 2, 3, 4. 4 electrons are used as a bond pair. So 6 minus 4 minus 2. So total formal charge is 0, means charge on this oxygen is 0. What is formal charge? Formal charge is nothing but the charge of individual atom in a polyatomic molecule. See, when we are writing NO3 minus, means this negative charge is the charge of entire polyatomic molecule. But which atom occupying this negative charge, if you want to know that, then we must know the formal charge. Just by calculating the formal charge of each and every atom of polyatomic molecule, we can easily know what is the charge of individual atom. So again, this one having the formal charge is 0. If we want to calculate the formal charge of this oxygen, say it's a third oxygen, it's a third number oxygen, right, of third, then first we have to write down that is the valence electron, that is the valence electron. Valence electron minus lone pair minus bond pair electron divided by 2. Now formal charge of third. So in the third also there is oxygen. Oxygen is belongs to group number 16. So valence electron are 6 minus. Now here we have to know the number of lone pair electron. Oxygen having a total 8 electron around it. Out of this 8, 2 are used in this bonding. So how many remains are there? Total 6 are there. Total 6 are there as a lone pair electron. So I will write down 6 minus bond pair. Bond pair is 1 and 2. So total 2 bond pair electron. So I will write down 2 by 2. Right? So my formula gives me value that is 6 minus 8. So it's a 6 minus 7. 6 minus 7, that is equal to minus 1. So my third number atom, that is this oxygen, having the charge is minus. Right? If we want to calculate the formal charge of this nitrogen, then again formal charge of second, that is the second one, second atom, we can say valence electron. How many valence electrons are there? So nitrogen is belongs to which group? That belongs to group number 15. So valence electrons are 5. Now lone pair electron, see 1, 2, 3, 4, 5, 6. So 6 electrons are used in their bonding. So only 2 electrons are remain. So I will write down that is the 2. That's the 2. Right? There are the lone pair electron. And bonding electron, 1, 2, 3 bonds are there. Each bond occupy 2 electrons. So total 6 electrons are there. So 6 by 2. 6 are the bonding pair electron. Bonding electron. Bonding electron means electron that used in making the bond. Nitrogen having a 2 bond on one side with the oxygen and 1 bond on other side with the oxygen. So total 3 bond, each bond having a 2 electrons. So total 3 to the 6, 6 electrons are there. Now I calculate formal charge, then it becomes 5 minus 2 minus 3. So total becomes 0. Means this nitrogen having a 0 formal charge. Oxygen also having a 0 formal charge. So this oxygen having a 0 formal charge, this nitrogen having a 0 formal charge, this oxygen having a minus 1 formal charge. In this way you can calculate formal charge of any atom in a polyatomic molecule. Both of this trick, how to calculate the formal charge and maximum valency, is very useful in drawing the Lewis dot diagram. That's why before starting the Lewis dot diagram we have discussed both of this concept. Now let's go through some rules that required to know for drawing the Lewis dot diagram. Rule for the center atom. See, center atom and corner atom, 2 types of atoms are there in a Lewis dot diagram. Now what is the center atom and what is the corner atom? Let us see. For example, if I talk about the H2O, then in a H2O, oxygen is a center atom and 2 hydrogen are on a side by. So I can say these are the corner atom and this is the center atom. So our rule says that least number of atom is the center atom. Here in H2O, total 3 atom, 2 hydrogen and 1 oxygen. So least number of atom, that is the 1, that is the oxygen. So oxygen placed here as a center atom. This is the thumb rule, that least number of atom means atom having the minimum number is here. Number doesn't means atomic number, number means simple number, their counting number. So oxygen having the least number is placed as a center atom. Then least electronegative element is in center. Always center atom having a electronegativity is very less. Larger size element is in a center atom. Any element which is in a larger size among polyatomic molecule is always placed as a center atom. Then highest atomic number element is in a center atom. So here hydrogen having a 1 atomic number, oxygen having a 8, again hydrogen having 1. So highest atomic number is of oxygen. That's why also we have placed it here on a center atom. Likewise, you have to use this concept, these rules in all Lewis dot diagram, because in a Lewis dot diagram it is very important that which atom you are considered as a center atom. These are the rules for the center atom. So based on this rule we can say very easily that in a periodic table hydrogen and fluorine will never become a center atom, because fluorine is the highly electronegative, so it's not a least electronegative, so it will never become a center atom. Hydrogen very smallest in the size, definitely smallest size element cannot be center atom, because our rule says that largest size element is a center atom. So hydrogen and fluorine never use as a center atom. Then center atom may have 8 electron or more than 8 electron. Whenever you are maintaining the octet of center atom, so this center atom may have minimum 8 electrons is essential. 1, 2, 3, 4, 5, 6, 7, 8. Center atom must have minimum 8 electron. But sometimes it may have more than 8 also. Sometimes it may have more than 8 also. But as far concerned to corner atom, then corner atom always occupying 8 electron surrounding it. 2 electrons are used in this bonding and remaining 6 are there on its. So center atom may have 8 or more than 8, but corner atom must have complete octet, means only 8 electron. You cannot put 9 electron around corner atom, always maintain 8 electron. Now center atom always occupy positive charge, never negative charge. And corner atom always occupy negative charge, not a positive charge. It never occupy a positive charge. Right? So these are the some simple rules. Draw the Lewis dot diagram. Now, as I discussed in a calculating the valency, so this is the ready reference to you. Just take the screenshot of this so you can know how many valence electrons are there in some important element, right? And center atom is always trying to maintain the maximum valency, that is the thumb rule, right? So next rule, that is the calculate the total number of electron. Whenever you are going to prepare a Lewis dot diagram, the first step that you have to do, that is the total number of electron. This total number of electron is always denoted by Q. So it is nothing but it's a valence electron of all atom plus negative charge of on molecule. Now negative charge on molecule means what? Say if you are taking for example NO3 minus. So minus is the negative charge on polyatomic molecule. So if there is here there is a -1. So in that case you have to add 1 to the valence electron of atom. We will discuss it in a detail when we are going to take some example, but presently let you know only things is that valence electron plus number of negative charge. If there is a 2 negative charge, then I have to add 2. If there is a 3 negative charge, for example PO4 minus 3, in that case PO4 minus 3. In that case, I have to add 3 here, because negative charge is always added to the valence electron. Similarly, if positive charge is there, for example, aluminum plus 3, if positive charge is there, then it is always subtracted from the valence electron of all atom. In a polyatomic molecule, I have to calculate the valence electron of all atom, and I have to add the charge. I have to subtract the total valence electron here. Then we also have to calculate the bond pair electron. It is very easy to calculate bond pair electron. Bond pair electron is nothing but twice of number of bond. So if you multiply 2 by number of bond, that is the bond pair electron. Then you need to calculate the lone pair electron also. Lone pair electron is nothing but it's a difference of total electron and bond pair electron. If you subtract the bond pair electron from lone pair electron, you will get number of electron. Those are the lone pair electron. Now lone pair electron in a Lewis dot diagram we are putting are always used either in making the double bond or triple bond. Okay, now let's take one by one example and we prepare the Lewis dot diagram so we can understand how to use all these rules, where to use formal charge, how to calculate the valency, maximum valency, and where we can use all this concept. For example, if we take example of NO2 minus 1, right, negative 1. So here total number of valence electron of nitrogen and 2 oxygen. So nitrogen having a how many electron? Nitrogen is belongs to group number 15. So total 5 electron. Plus there are 2 oxygen. There are 2 oxygen. So I have to put 2 multiplied by how many number of electron, how many number of valence electron in oxygen. Oxygen is again belongs to group number 16. So total 6 electrons are there. So each oxygen having a 6, there are 2 oxygen. So 2 into 6. So total is a 12. So I can say 5 plus 12, that is the 17 plus. Now here negative 1 charge. Here negative 1 charge. So according to our rule, if there is a negative charge, I have to add that value to total electron. So here I have to add plus 1. Why I have to add plus 1? Because there is a negative 1 charge on NO2. So total valence electron, that is the 18. So I have added plus 1 here. This is the total valence electron. Now I have to calculate the bond pair electron. Now in NO2, 2 oxygens are bonded to nitrogen. So total 2 bonds are there. Bond pair electron is nothing but twice of total number of bond. So I can say 2 into 2, that is equal to 4. That is equal to 4. So I am having a 4 is the bond pair electron. So now if I want to calculate the lone pair electron, then it is nothing but total electron, total valence electron minus bond pair electron. So I can say that's the 18 minus 4. So 14 is the lone pair electron. So in a step number 1, we have to calculate the total valence electron. How we can calculate total valence electron? By adding the valence electron of each and every atom in polyatomic molecule. Then bond pair electron. How to calculate bond pair electron? Twice of total number of bond. Lone pair electron is nothing but difference of Q and bond pair electron. So 14. So in a now third step, you have to place all those 14 electron on this atom. Whenever you are putting the lone pair electron, take extreme care, because if you make a little mistake in putting the lone pair electron, you will get Lewis dot diagram is very incorrect. So I'm starting to put 14 electron. I have to put 14 electron. So first you choose to put electron on a corner atom. Our rule says that corner atom must have a 8 electron. It must occupy the octet. So in order to fulfill its octet, use this valence electron. For example, if I want to fulfill the octet of this oxygen, then 8 electrons must be there. Now 2 electrons are there in a sharing, that's with the oxygen. So 1, 2, 3, 4, 5, 6, 7, 8. So total 6 electrons are used in oxygen. Then still I am having a 8 electron. So again I have to use octet of this oxygen also. 1, 2, 3, 4, 5, 6, 7, 8. So 6 plus 6, 12 electrons are already used. Still 2 electrons remain as a lone pair electron. So now give chance to center atom. So first you have to use the lone pair electron for the corner atom. Once all corner atom occupy their octet, then and then only you put electron on a center atom, because our rule says that center atom having a minimum 8 electron, but it may have more than 8 electron also. Now in a nitrogen here 1, 2, 3, 4, 5, 6 electrons are there only. So octet of this center atom is not maintaining. Octet of center atom is not maintaining. So what I have to do? I have to maintain the octet of this center atom. So I will put here double bond and here single bond. Once I put double bond here, I have to use the lone pair of corner atom. Remember, this is the thumb rule. Whenever you are maintaining the valency of center atom or you are maintaining the octet of center atom, then you have to use the lone pair electron for making the double bond and triple bond, and that lone pair electron must be of a corner atom. So this corner atom is giving its 2 electron, giving this 2 electron in making this double bond. So now this oxygen having a only 4 electron as a lone pair electron. This oxygen having the same scenario, 6 electrons are there. Now in a polyatomic molecule, we have here written that -1 charge is there on a polyatomic molecule. Now question arises, where I have to put this -1 charge among all these 3 atoms of this polyatomic molecule. I can put here, here or here. That's a confusion. In that case, your concept of formal charge will help you to know where to put a negative charge. Say this is the one, this is the second atom, and this is the third atom. So if I calculate the formal charge of first, that's in just before this page we have already calculated the formal charge of this oxygen, that was the 0. So his formal charge is 0. If you calculate the formal charge of second, that's nitrogen, that is also 0. If you calculate the formal charge of third one, then it gives me -1. So I will say negative charge will be on this atom. So my Lewis dot diagram gives me structure like this. Let's take one more example. Say now take NO3 minus 1. Now we'll take NO3 minus 1. So total valence electron, that is the Q, is equal to nitrogen having the 5 valence electron because belongs to group number 15, plus 3 oxygens are there, each oxygen having a 6 electron, and -1, -1 charge is there. So definitely I have to add +1. So total valence electron, that is 5 plus 18 plus 1, that is the 24. So my total valence electron in this polyatomic molecule, that is the 24. Now bond pair electron. For bond pair electron, I have to draw the structure. Now there are 3 oxygen. One is here, second is here, third is here. You can put this oxygen on the upper side, no matter, but you have to put corner atom in a way that there are minimum repulsion between them. So in calculate the bond pair electron, I have to know the number of bond. So 1, 2 and 3 bonds are there because 3 oxygen are bonded to center atom nitrogen. Nitrogen I have taken as a center atom. Why? Because it is larger in size, it's less electronegative than oxygen. Further, it is a least number because 3 oxygen and 1 nitrogen is only there. So 1 nitrogen is the least in a number, so I have to consider it as a center atom. So now bond pair electron, that is a 3 bonds, so 2 into 3 is equal to 6. And what about lone pair electron? Lone pair electron is nothing but total valence electron minus bond pair electron. So I can say that 24 minus 6 is equal to 18. So 18 is the lone pair electron. Now carefully let us put this 18 valence electron on this structure. So first rule is always use this 18 valence electron for fulfilling the octet of corner atom. So 1, 2, 3, 4, 5, 6, 7, 8. So total 8 electron on this oxygen. Again 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons are there on this. Similarly 1, 2, 3, 4, 5, 6, 7, 8. So I have maintained the octet of all corner atom by using this lone pair electron, because I have 18 lone pair electron. So each oxygen are placed 6 lone pair electron, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So 6 3s are 18. So all 18 electrons are consumed. Now nitrogen is the center atom, and center atom also have a octet, but here 1, 2, 3, 4, 5, 6, only 6 electrons are there. So octet of center atom is not maintaining, and it must have a octet. So in order to maintain the octet of center atom, let us make a double bond from any of this lone pair electron, right? So let us use this lone pair electron for making the double bond. So our new structure is like this: oxygen, nitrogen, double bond oxygen and oxygen. Okay. Now -1 charge was given on a polyatomic molecule. Now question arises where I have to put this -1 charge, right? So in that case, again I have to calculate the formal charge of each and every corner atom. Say this is the first, second and this is the third, right? If I calculate the formal charge of first one, then VLB by 2, valence electron of first atom. First atom is the oxygen. So valence electron of oxygen is nothing but it's a 6. It's a 6. How many lone pair electrons are there on this oxygen? There are 1, 2, 3, 4, 5, 6 lone pair electron. How many bond pair electron? Only 2 bond pair electron are there. These 2 bond pair electron are there. So 2 by 2. So its formal charge become -1. That's the -1. Again, formal charge of this first and formal charge of second will be same. Why? Because first and third will be same. Why? Because first and third both having a same scenario, same kind of bonding with the nitrogen in same number of lone pair electron. That's why I can say that this first number oxygen and third number oxygen having the same formal charge, that is a -1. Now if we calculate the formal charge of second oxygen of this oxygen, then again I have to put number of valence electron of oxygen is 6. Now here if we talk about the lone pair, then initially oxygen had 1, 2, 3, 4, 5, 6 electron as a lone pair. But out of the 6, 2 were used to making the bond. So 2 are consumed in making the bond. So now there are only 4 valence electron. So I will say 4 minus. Bonding electron, there are 2 bonds. So total 1, 2, 1, 2, 3, 4. 4 electrons are there. So 4 by 2. So I can say that 6 minus 4 minus 2 means 0 is the formal charge. So this oxygen having a 0 formal charge, this oxygen having a -1 formal charge, this oxygen having a -1 formal charge. But in our structure, in our formula of polyatomic molecule, there is only -1 formal charge. Here we are getting the -1 of this as well as this. So in that case we are representing this structure like this: nitrogen, double bond O, oxygen and oxygen. Now -1 charge is distributing between these two. So we are putting like this, -1 charge like this, because -1 charge is continuously resonating between this oxygen. That's why we are putting like this. Now let us see. Let us take one more example. We take next example, that is of a SO3-2. Now in SO3-2, first step, that is the calculate the total number of valence electron, that is the sulfur is belong to group number 16. So 6 is the valence electron, minus 3 into 6, because oxygen also belongs to 6. Now there is a -2 charge, so I have to add +2. So total valence electron are 26. If it calculate the bond pair electron, then sulfur is bonded with 3 oxygen. So total 3 bonds are there. So total number of bonding bond pair electron are 2 into 3 is equal to 6. And lone pair electron is nothing but difference of total valence electron minus bond pair electron. It's a difference of total electron and bond pair electron. So 26 minus 6, so total lone pair electron are 20. Now I have to distribute this 20 electron among all these 3 corner atom in a way that each atom can fulfill their octet. So 1, 2 are there, 3, 4, 5, 6, 7, 8. Octet of this oxygen is already maintained. Now 1, 2, 3, 4, 5, 6, 7, 8. Octet of this oxygen is also fulfilled. 1, 2, 3, 4, 5, 6, 7, 8. Right? So 6 plus 6, 12 plus 6, 18. So out of 20, 18 electrons are used in maintaining the octet of all 3 corner atom. Still I am having a 2 electron. So I have to put this 2 electron on a center atom. Give priority to fulfill the octet of corner atom, and after corner atom, if you are having still any lone pair electron, then utilize that lone pair electron for a center atom. Now in this structure here, my sulfur is the center atom. So 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons are also with the sulfur and 8 electrons with the corner atom. So octet of corner atom as well as center atom is fulfilling very well. But as we know, friends, maximum valency of sulfur is 4. So in order to utilize its maximum valency, sulfur will make a double bond. Why it will make double bond? Even after having a 8 electron around it, although sulfur have fulfilled its octet, even though it will make double bond, because maximum valency of sulfur is 4, and valency is nothing but number of bond that element can form. So sulfur having a tendency to form a 4 bond with surrounding atom, and maximum valency 4 is always maintained by the center atom. So whenever you are seeing any center atom, then remember that it will try to maintain its maximum valency. Below maximum valency, it's highly unstable. So these 2 electrons are used in making the double bond. As I told earlier, that whenever you are making a double bond, use the lone pair of corner atom only, not of a center atom. So now my new structure, that is oxygen, sulfur, oxygen, and double bond oxygen. If you calculate the formal charge here, then if this is the first, second, and third, you will find formal charge of 1 will be the formal charge of 1 will be -1, then formal charge of second also -1, and formal charge of third is 0. So this oxygen having a 0 formal charge, here -1, -1. So again its resonating structure is something like this. Sulfur double bond, oxygen, say here is the negative charge, the negative charge is not there. Sometimes you will find sulfur double bond O, oxygen, and negative charge is on this. So its common structure is like this: oxygen, oxygen. So this negative charge is continuously in movement between these 2 oxygen. So this is the common structure we can prepare of this SO3 -2. Let's take one more example. Say CO3 -2. CO3 -2. So again, total valence electron, that is the carbon having the 4 plus 3 into 6, because oxygen having 6, -2 is charge, so I will put here +2. So total 12 plus 4 16, 18, plus 4 22, plus 2 24, so total 24. If we talk about the bond pair electron, then carbon having a 3 oxygen, so 3 bonds are there, so total bond pair electron are 6. If we talk about the lone pair electron, then it's a 24 minus 6 is equal to 18. So I have to put 18 electron, each oxygen having a 6 electron, so it can maintain its octet very well, as we discussed earlier. So 1 2 3 4 5 6 7 8. So all corner atom have fulfilled their octet now, and all 18 lone pair electron are already consumed. Now we know, friends, the maximum valency of carbon is 4, but here carbon having only 3 bond. So according to maximum valency 4, it must have a 4 bond, right? Further, 1 2 3 4 5 6, octet of carbon is also not maintaining here. So to maintain the octet of carbon, to maintain the maximum valency of carbon, carbon will make a double bond, and whenever we are making double bond, we have to use the lone pair of corner atom. You can use lone pair of this corner atom, or this one. Any corner atom can utilize their lone pair, but for most convenient way, we are always taking the lone pair of this right one corner atom. So my structure will be like this: oxygen, carbon, double bond, oxygen, and oxygen. Right? So this is my structure. If you calculate the formal charge of each and every oxygen, say this is the first, this is the second, and this is the third. Now you are very well know how to calculate the formal charge. So if I calculate the formal charge of this first atom, it will be -1. Formal charge of second atom, this is the -1. Formal charge of this third, that would be 0. How to calculate this formal charge? We have already discussed in our video in an earlier part, right? What is the formula of calculating formal charge? We have already discussed it in our earlier part of this video. So I'm directly putting charge over it. So again, in a CO3 -2, -1 charge is oscillating between this oxygen. So I will put it like this, like this. So this is the -1 charge among this oxygen. Sorry friends, there are -2 charge is there, means not a single electron between two oxygen, but each oxygen having a -1. So this is not the proper way. We can directly put -1 on this charge and -1 on this charge, because CO3 having a -2 charge. -2 charge means I have to utilize 2 times -1 minus -1 -1. So this oxygen also having a -1, this is also having a -1. So total charge is -2. So this 2 having a -2 is the charge. So here you will not get the resonance structure like this. You will get exact charge on both of these oxygen. They don't need to share their -1 charge among these two. Let's take one more example. Say SO3 gas. For example, we take a SO3 gas. Now in SO3 gas, gaseous form is there, so there is no charge over it. So total valence electron are 6 of sulfur plus 3 into 6 of oxygen. I don't need to put any +1 or -1. Why? Because there is a no charge on this polyatomic molecule. So its valence electron is 6 plus 18, that is a 24. If I talk about the bond pair electron, then its bond pair electron is, say, sulfur is bonded with 3 oxygen, right? 3 oxygen are there. So 1, 2, 3 bonds are there. So 2 into 3, so total 6 is the bond pair electron. If I calculate the lone pair electron, then lone pair electron is nothing but 24 minus 6, that is the 18. I have to put 18 electron like earlier. So I have to put this 18 electron in a way it maintain the octet of corner atom. So 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2. The 6 electron, lone pair electron with this oxygen, 6 with this one, 6 with this one. So total 18 electrons are utilized in this 3 corner atom. Now again here challenge is to maintain the valency as well as octet of center atom. Still octet of center atom is not maintained, because center atom having a only 6 valence electron, 1, 2, 3, 4, 5, 6, right? So in order to maintain the octet of center atom, in order to maintain the valency of center atom, again I have to put double bond, and for double bond we are always utilizing the lone pair of corner atom. So I will put, this is the final structure of SO3. Now here there is a 4 electrons are there on this oxygen atom, right? But 6 electrons are there on this 2 corner oxygen atom, but here there is only 4 atom, right? Now we know that octet of sulfur is already maintained, but still maximum valency of sulfur is 6. So in order to maintain this maximum valency, it will again make double bond with this 2 oxygen, and I will get the final structure of this sulfur is like this. What is the difference between our this structure and earlier? See, in a here SO3 is in a gaseous form, there is no charge, that's why we have maintained its maximum valency without putting any charge. But here scenario was little bit different. Here we had put a -1 charge, that's why we haven't used double bond here one more time, only one double bond was used. So this is the difference between these two Lewis-Dot diagram. So friends, let's take one example of PO4 minus 3. PO4 minus 3. In a PO4 minus 3, again total number of valence electron is 5 of phosphorus, because phosphorus belongs to group number 15. Oxygen belongs to group number 16. So 6 into 4, because 4 oxygens are there. Minus 3, -3 is there. So I have to add plus 3. I have to add plus 3. I have to put plus 3. So total number of valence electron are 5 plus 20, 25 plus 24 plus 20, 32. So total is the 32 is the valence electron. If we talk about the bond pair electron, then phosphorus is bonded with 4 oxygen. It is bonded with 4 oxygen, right? So total 1, 2, 3, 4 bonds. So 2 into 4 is equal to 8 is the bond pair electron. If we talk about the lone pair electron, then we can calculate by taking the difference of Q and BP is the 32 minus 8. So I can say it's a 24. 24 is the total number of lone pair electron. Now I have to arrange all these 24 lone pair electron among these 4 oxygen. So very crystal clear that each oxygen would have a 6 electron. So total 24 electrons are consumed in putting the lone pair on this 4 corner oxygen atom. So octet of oxygen is already fulfilled, but still octet of phosphorus is not fulfilling here. Further, maximum valency of phosphorus is 5. That is also not the octet of center atom. I will put a double bond here. I will put a double bond here by utilizing the lone pair of this oxygen. So I will get new structure like this. That is the phosphorus, double bond with this oxygen, single bond with this oxygen, and single bond with this oxygen, again single bond with this oxygen, right? So 5 maximum valency, 1, 2, 3, 4, 5 maintaining with the phosphorus very correctly. Octet is also maintaining 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here octet is not maintaining a phosphorus because you are getting more than 8 electron. What our rules was saying when we were discussing the rules in the initial part of this video, we told that center atom may have 8 or more than 8 electron. So here center atom having a more than 8 electron. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total 10 electrons are with the center atom in a sharing of this 4 oxygen. No matter if center having a more than 8, it's okay, nothing wrong. But corner atom must have total 8 valence electron. Now if we calculate the formal charge of each corner atom, say this is the first one, this is the second one, this is the third one, and this is the fourth one. The formal charge of first one is -1, formal charge of second is -1, formal charge of third is also a -1, and formal charge of fourth is 0, right? How to calculate this formal charge? What is the formula of calculating the formal charge? That we have already discussed in the earlier part of this video. Now -1, -1, -1, -1, -1, -1. So there are 3 times -1. So I will put one time -1 here, once time here, and once time here. So total there are 3 negative charge. Total 3 negative charge because PO4 having a -3 charge, right? So in this way we can draw the Lewis dot diagram of any atom or any polyatomic molecule. Friends, thank you for giving the time to this video, and I hope it would be very much useful, and you can now draw a Lewis dot diagram of any atom. Wish you all the best and God bless you.